Good morning all. Myself Dr. P.C. Praveen Kumar, Assistant Professor, ECE, G. Polarity Engineering College, Kurnool. Today I am here to discuss about Coulomb's law, which is in a subject of electromagnetic waves, syllabus. Today I am going to cover about what is Coulomb's law, what is the direction of force on charges, and followed by a problem. Before going to the Coulomb's law, we need to know about what is a charge. Here it is called as a charge, a point. Actually the point is having charge. We all know that every point or everything in a nature having a certain charge. Here we are going to concentrate on the charge on a static fields. Basically we can observe what is a charge means when we rub a comb for a bed sheet or a woolen sheet. After rubbing for 30 seconds, if we take near to the paper is going to attract to the comb. Or if we rub a small rod or a small stick to the cat aids, then after 30 seconds, if we go with anything, that one is going to attract. That is called as a charge. Or if you take a magnet, if we are nearing our magnet is going to near towards iron, it is going to attract the iron. Means iron are having a charge and a magnet is having a charge. Both iron and magnet both are having of a different polarities of charges. That's why different polarities will attract, opposite polarities will attract, and same polarities will repel. This is the basic thing we all know. With respect to the same, we have started the concentrating on a static charge. Static charge means the points which are not movable. That points we call as the static points. That points having a charge, that charge we called as a static charge. Here I am mentioning point 1 and point 2. These two are 2 points in a nature or in a separate place where 2 are fixed, not movable to one place to another place. That's why these two are called as a static charges. Now we need to know what is the force between the two charges, force between the P1 and P2, force of P1 due to P2, force on P2 due to P1. This one we need to know, because to know the remaining what the electric field, what the diversity, or whatever the density, or whatever the P fields we are concentrating to measure, first we need to know the charge as well as force between the two charges. Force on one charge due to second charge, that one we need to know. So to calculate all these things, we need to understand first the force. Then to know this force, we need to concentrate on a law called Coulomb's law of force. So this is the basic introduction. Now I am going a little bit further about Coulomb's law. Coulomb's law is one which is going to tell us the static force on 2 points of charges, two static force between 2 point charges of static fields. Here the Coulomb's law is going to concentrate or is going to tell about that force is directly proportional to the product of the two charges q1 q2. Let assume we are having a 2-point charges. The point name is p1 and a second point name is p2. These are the two static points. The charges of two points are p1, q1 and q2. Charges of 2 points are q1 and q2. The name of the charge points are p1 and p2. Now our force due to with reference to the Coulomb's law, force is directly proportional to the product of two charges and inversely proportional to the square of the distance. Here the distance between the two charges we called as r. Distance between the two charges are r. So the Coulomb's law is stating force is directly proportional to product of two charges and inversely proportional to the square of the distance. This is the basic equation for Coulomb's law. It's directly proportional to the product of the charges. It's directly proportional to the product of the charges and inversely proportional to the square of the distance. With this, the total equation is F is directly proportional to the q1 q2 by r square, inversely proportional to the r square. Now we need to know about what is this proportionality constant. Now our basic equation is F is proportional to the q1 q2 by r square. It can be written as F is equal to k into q1 q2 by r square, where k is proportionality constant. K is a proportionality constant. Now what is a k? K is equal to 1 by 4 pi epsilon naught, where epsilon naught is a epsilon naught is the permittivity of free space, which is equal to 8.854 into 10 power minus 12 farads per meters. Now we are going to substitute this epsilon naught value into our equation. Now k is equal to 1 by 4 pi into epsilon naught. That value, if you substitute, we are going to get 9 into 10 power 9 farads per meter. K value, proportionality constant, is equal to k into 10 power 9 farads per meter. Actually, if you go in depth, epsilon naught can be written as 1 by 36 pi into 10 power minus 9. 10 power minus 9. If you substitute this, 1 by 4 pi into 1 by 36 pi into 10 power minus 9. So if you solve this, we are getting 36 pi into 10 power 9 divided by 4 pi. Pi get cancelled. 6, 4 and 36. 34 9's 36. So it is 9 into 10 power 9. This is the k value. Now if we go with a complete solution, f is equal to 1 by 4 pi 1 by 4 pi epsilon naught q1 q2 by r square. Now the force can be written as q1 q2 by 4 pi epsilon naught r square. Now the force of point 1 and point 2, if this one I am calling as a origin, from the point, this one is a point 1, this one is point 2, the distance from the origin to the P1, the point 1, we call it as R1. This one we call it as R2. R1 and R2. Now the force of P1 is F1, force of P2 is F2, and the direction of the force of a unit vector, actually here to calculate all this we need to find a unit vector. To find the force of any point, we need to know the unit vector. Unit vector can be represented with r, or in some books small a, is equal to r dash divided by mod r. Here r dash is equal to r1 minus r2, and mod r will take as it is. So your unit vector can be calculated as r1 minus r2 by r. Mod r should be r itself. So this is the equation for the unit vector. Now how we are going to calculate the force? As we are having the 2 points, we need to calculate a force of F1 and force of F2, and a force of points due to two parameters. One is the force by same polarity, force by opposite polarity. Now this can be divided into two cases. The first case is having same polarity, that is q1, just assume q1 is having positive polarity and q2 also having positive polarity, or q1 is having negative polarity as well as q1 also having negative polarity, means both are having the same polarity. And the second case is opposite polarity, that is q1, if q1 is positive, then q2 is negative, or q1 is negative, q2 is positive. So like that we can divide. Now we can take case 1 where having same polarity. then we are going to take Q1, product of Q1 and Q2 are greater than 0. How means, if I have Q1 is 5 coulombs, 5 microcoulombs, Q2 is 10 microcoulombs, then product of Q1 and Q2 should be 5 into 10 microcoulombs. So here we are going to get only positive value, means Q1 Q2 product should be greater than 0. Q1 Q2 product should be greater than 0. Then what happens here? P1 P2, here Q1 and Q2 we are having, the distance is R, then the force here and here are moving like this. Okay, so here when same polarities, charges should ripple, go outside the region. Charges should ripple, which should go outside the region. So both are opposing to each other. Then we'll go to the case 2. When case 2, when Q1 Q2 are opposite, then we are going to get minus 5 coulombs and plus 10 coulombs. We are going to get minus 50, means here product of Q1 Q2 is greater than less than 0, because minus 50 are getting, so it is less than 0. Then what we are going to get? Q1 Q2 distance is R, where our forces are attracting each other. Forces are going inside the region, then your charges are going to attract. This one we know, opposite polarities are attracting each other. So here we have done two cases. The first case, when same polarities we are having, here the four charges are repelling each other. It is going away, here going away. That's why here it is, if it is in the same polarity, it is repelling. Then if you go to the opposite polarities, the forces, charges are attracting. When opposite polarities we have, charges are attracting to each other. So this is the case 2. Now we calculate the direction of force. Direction. So I am assuming again P1 point and P2 point. Here I am taking this one is the origin. From the origin, P1 is having the unit vector, the distance of R1, unit vector is R1. It is moving in this direction, and P2, the distance is R2, the direction is like this. Here the case 1, force will go in this manner. Force will go in this manner. This one is a force F1, this is the force F2. If you see in randomly, I'll take one color, the force direction and unit vector direction, both are different. Here force direction, unit vector direction are both are same. So with reference to this, if we are giving the same polarity, F1 is equal to minus F2. F1 is equal to minus F2. This one we have to prove. This one we are going to prove. We already know what is unit vector and all. So directly I am jumping. If here the condition is I am taking a same polarity. Same polarity, then what happens? Then here we concentrated on what is the direction of F1 and F2, what is the direction of unit vector. So now for a F1, I am calculating the direction of F1. Force on F1 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, and a unit vector is R1. Now what is a unit vector? Unit vector value is equal to R by mod R. This one is R1 minus R2 by R. Now we are substituting this value to here. Then what we are going to get is F1 is equal to 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught Q1 Q2 by R square into R2 minus R1 by R. That should be 1 by 4 pi epsilon naught Q1 Q2 by R square R cube into R2 minus R1. Q2 into R2 minus R1. This is for F1. If you go with a F2, what we are going to get is, here we are concentrating on R1. For a R2, what we are going to get is R by mod R, unit vector by mod R. That is here, if you go with this, here this is for R2. So we are calculating R2 minus R1. For this we are calculating R1 minus R2. Here we are calculating R2 minus R1. So here our equation is R2 minus R1 by R. So for F2 it should be 1 by 4 pi epsilon naught Q1 Q2 by R cube. Here, sorry, it is R1 minus R2. This one is R1 minus R2. Here it is R2 minus R1. R2 minus R1. Now this one, this is the equation for force on F first point, force on the second point of same polarities. Now we are equating these two. Then 1 by 4 pi epsilon naught Q1 Q2 by R cube R1 minus R2, which is equal to 1 by 4 pi epsilon naught Q1 Q2 by R cube R2 minus R1. So this proportionality constant is cancelled, product cancelled, R cube cancelled. Finally R1 minus R2 is equal to R2 minus R1. So if you take this one into a particular sequence, R1 minus R2 is equal to, I am writing this, I am taking this minus outside, and that's why minus R1 minus R2. So R1 minus R2 is equal to minus of R1 minus R2. So then F1 is equal to minus F2. This one we have proved with the help of unit vectors. F1 is equal to minus F2 when both fields are in a same polarity. When both fields are in same polarity, we are getting F1, force on F1 is equal to minus of force on F2, because same polarities will repel each other. Same polarities will repel each other. If same polarities are there, opposite polarities are there, then the equation will going to change as F1 is equal to F2. This is for same polarity. This is for opposite polarity. So this is about Coulomb's law. Now we're going to discuss about a small problem. Here the problem is having two static point charges. Q1 is equal to problem 1. Q1 is equal to 1 microcoulomb. Q2 is equal to 2 microcoulomb. And distance between each is 1 meter, and condition is having same polarity. So this is the condition. We need to find the force of F1 and F2. Force on F1 by F2, F2 by F1. These two we are going to find. To find this, just I am going to draw P1, P2, the distance is R. This point is Q1 is equal to 1 microcoulomb, Q2 is equal to 2 microcoulomb. Just we are going to solve the equation for force. Then F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square AR or R cap, unit vector. Unit vector can be represented with AR or R cap. That depends on which book you are going to follow. Don't confuse about this. AR and R cap both are same. So I am writing R cap for your convenience. Now just I am going to substitute 1 by 4 pi epsilon naught. Already we have solved in a previous slide. I will show. Here we solved 1 by 4 pi epsilon naught is equal to this one, proportionality constant 9 into 10 power 9. Now this one I am applying here to my problem. 9 into 10 power 9 into 1 into 10 power minus 6 into 2 into 10 power minus 6 by 1 meter. A meter is nothing but R square, 1 meter. Then you are going to get how much? That is equal to here minus 6 minus 6 minus 12 and plus 9. That should be minus 12 plus 9. That should be minus 3. So 9 into 1 into 2 into 10 power minus 3 by 1 meter. That should be equal to 9 into 2. That is 18 millicoulombs per meter. 80 millicoulombs per meter we can write. So like this we are going to solve. Here this is force. So as this one is given same polarity, F1 is equal to minus F2. This one we solved in a previous slide. So 18 millicoulombs per F1. If we assume the for F2 is minus 18 millicoulombs. This is for F1. This is for F2. So like this we are going to solve. Up to today we'll conclude here, and for the next part of Coulomb's law we are going to concentrate on force on multiple points. Here today we have done only for 2 points. For tomorrow we are going to done with multiple points, and followed by some problems. Thank you.